Welcome to this explainer from Unlock UPSC. Today we're tackling a really crucial editorial, one that's vital for your understanding of science and technology policy, especially for exams like the UPSC, UPPCS, and BPSC. So here's the situation. There's a new government directive that wants to aim India's PhD research squarely at the country's most immediate problems. Now, this has kicked off a huge debate. Should our sharpest minds be focused on solving today's issues, or should they have the freedom to chase the unknown breakthroughs that could define our future? We're going to break it all down, looking at every angle of this and what it really means for India's long-term STEM potential.
All right, let's dive right in. Here's our game plan. First, we'll get a clear picture of what this new government directive is all about. Then we're going to look at the other side of the coin, the incredible value of basic, curiosity-driven research. This will give us a critical lens to view the policy. After that, we'll get to what might be the real heart of the issue, the deep-seated hygiene factor crisis that's affecting our universities. And of course, we'll wrap it all up with some solid takeaways and a practice question tailor-made for your mains exam prep.
So, what's all the buzz about? Well, this whole conversation starts with the new government directive that's looking to shake up how PhD research is funded and guided in India. The main idea? To forge a really strong direct connection between the research happening in our universities and the most urgent problems our nation is facing right now. This line right here, this is the essence of the policy. The government wants to steer Doctor of Philosophy programs so they become engines of innovation for India's current challenges. It's a pretty big shift, moving away from that classic blue sky, purely academic kind of research and towards a much more targeted, mission-driven style.
So, what's the thinking behind this? Well, from the government's point of view, the logic is pretty strong. This is the pro side of the argument, if you will. First, it makes sure that academic work actually helps solve real national problems, in areas like renewable energy or healthcare. Second, it's about accountability. When public money is being spent, the government can point to specific problems being solved. This means prioritizing tangible, immediate results. On the surface, it sounds incredibly pragmatic, doesn't it? But, and this is the big question for any policy analyst, does focusing so much on the now come with a hidden price for the future?
Okay, so let's flip the coin and look at the cons of this approach. While having research with immediate applications is definitely appealing, focusing only on what we need this very second could have some serious long-term consequences. And this is where the real debate fires up. It's the urgency of today versus the unknown potential of tomorrow.
This slide just lays out the central conflict perfectly. On one side, you have the government's approach, a straight line to solving today's problems, where you can easily measure progress. On the other side is the author's view, exploring the vast landscape of knowledge to build a foundation for future challenges, many of which we can't even imagine yet. The value in that is often indirect and much harder to put a number on in the short term. So are we on a targeted mission or a foundational exploration?
And here is the absolute key point. Applied science doesn't just magically appear. Think about it. The technology we use every day, from our smartphones to life-saving vaccines, it all grew from the seeds of basic, curiosity-driven research planted years, sometimes decades ago. There's a time lag. If we stop watering those seeds of basic research today, we're basically guaranteeing a technological drought in the future. You want a perfect example? Look no further than the 2022 Nobel Prize in Physics. It went to scientists for experiments they did back in the 1980s, exploring the really weird rules of quantum mechanics. Back then, nobody knew what to do with it. It was pure science. Fast forward 40 years, and that exact research is now the bedrock of quantum computing, a technology that could change everything. Those scientists weren't trying to build a supercomputer, they were just curious, and that curiosity is what paved the way.
History is full of examples that prove this. Take the legendary Bell Labs. This was a for-profit industrial lab, but it gave us the transistor, the laser, fiber optics, inventions that built entire industries. What was their secret? They understood the power of basic research. They gave their scientists the freedom and the money to explore ideas that had zero immediate connection to their business. That freedom to just be curious is what led to breakthroughs that changed the world.
Now, moving beyond this high-level debate of basic versus applied research, the editorial brings up something far more urgent, something much more fundamental. It argues that before we can even think about putting any new policy into place, India has to fix the systemic problems that are basically crippling our research ecosystem from the inside out. The editorial uses this really powerful idea from management theory called hygiene factors. Let me break it down. Think of these as the absolute basics of any job. Things like a fair salary, a safe place to work, or, just getting paid on time. Now, having these things doesn't necessarily make you passionate about your job, but not having them, that's a huge source of dissatisfaction and demotivation. You don't get excited that your office is clean, but you'd be pretty unhappy if it was filthy, right? That's a hygiene factor. So the big question is, what are these missing hygiene factors in India's research system? What are the basic failures that are actively pushing our brightest minds down and stopping them from doing their best work? The article gives some pretty troubling answers. First, let's talk about the pay, which is shockingly low. Many PhD students who are funded by their universities and haven't cleared the National Net Fellowship get a stipend of just 8,000 rupees a month. Just let that number sink in. That's below minimum wage in many parts of India, and it hasn't changed since 2012. This kind of financial pressure forces our researchers to take on side jobs just to survive, stealing precious time and focus away from their actual research. And you know what's worse than being paid poorly? Not getting paid at all. The author shares this really personal story about a friend who won a prestigious government fellowship but hadn't received a single rupee of her stipend for 9 straight months. And the most chilling part of that quote is the end. Her case is not atypical. This isn't a one-off problem. It's a systemic crisis of payment delays, leaving our country's researchers in a constant state of financial anxiety. So to sum up these core issues, we have fellowship payments delayed for months. We have stipends that are frankly insulting. We have this huge gap between our universities and private industry, which means fewer opportunities for funding and collaboration. And on top of all that, the universities themselves often can't step in to help because of rigid, bureaucratic rules. These aren't just small cracks. They are fundamental flaws in the system. The article then zooms out a bit, warning us against focusing exclusively on the STEM fields. It makes a powerful case that for India to truly prosper as an innovative nation, we need a more holistic approach, one that values every field of knowledge. So, why do fields like history, sociology, and philosophy matter so much? Well, for one, they are crucial for a healthy democracy. They let us ask tough questions about our society and ourselves. These are also the fields that are most at risk when research funding gets tied to politically defined national priorities, which can shift and potentially stifle independent thinking. And here's the kicker. Ignoring the humanities doesn't create better scientists and engineers, it just creates narrower ones. Real innovation often sparks at the crossroads of different disciplines. And this really brings us to the author's powerful, central argument. It's simple, but it's profound. Before we start chasing fancy new research goals, before we try to overhaul the whole system, we have to fix the basic hygiene factors: paying researchers a livable wage, paying them on time, and creating a truly supportive environment. These are the non-negotiables. Because if we don't get these basics right, any new policy, no matter how good it sounds, is being built on a foundation of sand. It's bound to fail. All right, let's pull all of this together into some structured points that you can use directly when you're writing your mains answers. A question on this topic really demands a balanced view, and these next few slides are designed to help you build that effective argument. So, if you're arguing for the government's directive, here are your key points. First, it directly connects research to national needs, making academia a partner in building the nation. Second, it creates accountability for how public money is spent. Third, it pushes for real-world innovation in key areas. And finally, it makes progress measurable, which is crucial for good policymaking. This is the argument for being pragmatic and getting immediate results. Now, for the counter-argument, in favor of basic research, here's what you'll want to use. First, it builds our long-term ability as a nation to handle challenges we can't even predict yet. Second, it respects the historical fact that today's applications come from yesterday's basic discoveries. Third, it helps create a true culture of curiosity and innovation, like we saw at Bell Labs. And finally, it supports the very idea of creating knowledge for its own sake. This is the argument for having a long-term vision. This table is a super useful way to structure your points on the challenges in our research system. You can use this framework to talk about how delayed fellowships cause extreme financial hardship, how inadequate stipends force researchers into side jobs, how the gap between academia and industry leads to missed opportunities, and how undervaluing non-STEM fields ultimately narrows our country's intellectual growth. And finally, for your conclusion or the way forward part of your answer, these steps give you a balanced, complete solution. Number 1, and the most urgent, fix the hygiene factors. Timely and fair payment is non-negotiable. Second, we have to actively build bridges between industry and our universities. Third, while we encourage applied research, we must also carve out and protect funding for curiosity-driven basic research. And fourth, We need to build a truly holistic ecosystem that values both STEM and the humanities. It's not an either-or choice. A modern nation needs both to succeed.
And that brings us to a practice question for you to think about. A narrow focus on research with immediate applications can be superficially attractive, but detrimental to long-term national innovation. Critically analyze the statement in the context of India's research ecosystem and suggest a balanced path forward. This question really covers the whole debate we've had today. I really encourage you to use the points we've discussed to build a solid, well-rounded answer.
See you again tomorrow with an important editorial. For this, subscribe to the YouTube channel Unlock UPSC. Thank you.